so we're continuing with the notes from yesterday. All right, so this is where we are. So yesterday the identities that we did were called sum and difference identities. We're going to cover two other categories of identities today, double angle and half angle. So again, the point of these is to find exact values of trig angles, trig functions of angles that are not on the unit circle, using angles that are on the unit circle. Okay, so double angle identities. Pull your identity sheet out. Do you see where double angle identities are found? Right here. Underneath the reciprocal identities, so let's highlight those. All right, so these are formulas that enable us to take information from theta and find information on 2 times theta, whatever that doubled angle may be. Notice that there are 3 different formulas for cosine. Here's the sine 2 theta formula, but there's 1, 2, 3 different formulas for cosine 2 theta. And they're all totally different. You just have a choice of which one you use for cosine 2 theta. So we'll talk about how you choose which one in just a minute. And then tangent 2 theta is down here at the bottom. Okay, so like yesterday, we're just going to see how they are used. Thank you. So we're going to just jump right in. We're going to prove the very first one. So this first one is sine of 2a equals 2 times sine a times cosine a. We're going to prove that that's true. So with an identity, we take one side, change it until it becomes the same as the other side. I'm going to work on the left-hand side here and say that sine 2 theta is the same as sine of theta plus theta. Is that true? X plus x is 2x, so theta plus theta is 2 theta. Well, now, if I write it that way, I can use a sum or difference identity that we talked about yesterday. So since it's sine and it's added, I'm going to use this top formula right here. And when it's added here, it will be added over here on the right-hand side. So I'm going to set this up. But what is my A and B value here? Theta and theta. This is A, this is B. So they're both going to be theta. So that's kind of interesting. Let's see what happens. All right, so I have sine of A is sine of theta. Cosine of B, but B is also theta, plus cosine of A, which is theta, times sine of B, which is also theta. So A and B are both theta, so you don't really have to think about it. Wherever there's an A or B, we're putting theta in its place. Okay, so I have 1 sine cosine plus 1 cosine sine. Multiplication is commutative, right? That's the same, isn't it? Like 3 times x and x times 3 are the same thing. So really I have 2 of these. So that equals 2 sine cosine. And that is exactly what we wanted to get over here on the right. Question? I changed 2 theta into theta plus theta. Just like 2x is x plus x. No? If you have x plus x, that's 2x, right? So I was just taking 2x and changing that into x plus x. So I took 2 theta and changed it into theta plus theta, so that I could use that sum formula that we used yesterday. Okay, any other questions on that one? All right, use a double angle identity to help solve for x on the interval. Okay, so now we're solving an equation. So I want to find eventually answers that are angles from 0 up to 2 pi on the unit circle. But this is my equation. So it's already sine, that's already cosine, but notice this is 2x and this is just x. So what I'm going to do is change sine 2x to this formula right here. I'm going to change it to 2 sine x cosine x. So using double angle identity, the left-hand side can be substituted. And again, on this sheet, I'm just using that very top sine 2 theta formula. Now, why does that help? Because now everything is just cosine or sine of x. Okay, how am I going to solve it from here? What would you do to solve this equation? You had several like this earlier in the week. Can't divide by cosine because we're throwing out a solution. What did we do instead? Subtract cosine. So that it's equal to 0. And do what now? Oh, well, first of all, are these like terms? Did the signs subtract away? No. Charles is saying no. He's right. What can I do on the left? Factor out what? Cosine. Both terms have a cosine in them. So I'm going to bring cosine out of each term. What's left is 2 sine x minus 1. Okay with that? All right, so that zero product property, if the product of these two things is 0, the only way that can happen is if cosine x is 0 or 2 sine x minus 1 is 0. Okay, well, this one I can go to my unit circle, figure out where cosine is 0. This one over here, I'm going to do a little bit of work first. I'm going to add 1 to both sides, then divide by 2, and look for where sine is 1/2 and where cosine is 0. So we're going to get the unit circle. Find for me where cosine is 0. Okay, Lee, tell me when you have one. Good question. I think this is what you're going to ask, degree or radian. Okay, if I'm giving you the domain in radians, give me answer in radians. If it's given in degree, give degree. So what's your first answer you have there? Pi over 2. Nice. Okay, who can add a solution to this? All right, Rhett. 3 pi over 2. Both of those are where cosine is 0. Now, someone find me where sine is 1/2. Pi over 6, aka 30 degrees, right? And any others? 5 pi over 6. Nice. Did we get them all? If I'm not looking for plus or minus, only positive, then we got them all. When do I do plus or minus on these? When I square root both sides. Nice. Question on that? Okay, let's see. If theta is an acute angle in a right triangle and sine theta is 3/5, draw the triangle and find sine 2 theta, cosine 2 theta, tangent 2 theta. All right, so here's my right triangle. Theta can be either of the acute angles. Doesn't matter, just label one of them. And the fact that I'm giving you sine tells me I'm giving you what over what? Opposite hypotenuse. Okay, so let's label those. Opposite theta is 3. Hypotenuse is 5. Do you know this Pythagorean triple? 4. Yeah, 3, 4, 5. You see in a lot of trig-related problems because it's the smallest Pythagorean triple that's all integers. 3, 4, 5. So you see that one a lot. But if you don't recognize it, you would use your Pythagorean theorem to find the missing side. Okay, so I'm not actually finding theta. I just want to know what sine 2 theta is. So without knowing what theta, I don't know what 2 theta is. But I can apply this formula here 2 sine theta cosine theta. So sine 2 theta is 2 sine theta cosine theta. All right, well, sine theta I was given. That's 3/5. Cosine theta I wasn't given, but we found the missing side, so we can figure out that cosine is adjacent over hypotenuse. So that will be 4/5. And then I'm just going to multiply those together. Keep in mind that that's 2 over 1. And we multiply fractions, we just multiply straight across. So sine 2 theta is 2 times 3 times 4. What does that equal? 24. Over 1 times 5 times 5, 25. So without finding theta, I can still tell you what sine 2 theta is using the formula. Question? Okay, for those of you who do major in something math related and end up having to take like 3 calculus classes in college, a lot of these identities that we're using are used to simplify problems in higher math. Like nobody's actually just sitting around finding sine 2 theta. We're just manipulating these formulas, but they do come in handy in some advanced math courses when you're trying to break something down and make it a little simpler than it might start out being, in case you were wondering. All right, cosine 2 theta. This is the one that we have 3 options. Sometimes you may only know information about cosine, and then in that case I would use that middle one. Sometimes you might know only information about sine, in which case I would use the third one. We know sine and cosine, so we could use any one of these 3. I think I'm just going to use that first one, cosine squared minus sine squared. But since we know sine and cosine, any of those would be an option for us. What does this make you think of, but it's not quite the same as? Pythagorean identity, yeah, because it would have a plus in the middle. So it kind of makes us think of that, even though it's different. Okay, so cosine squared means find cosine and square cosine. So if I go over here to the triangle, cosine is adjacent over hypotenuse. That's 4 over 5. But I'm going to square it. That's what cosine squared means. Find cosine and square it. Minus sine squared. Go to your triangle or just go to the given information. Sine is opposite over hypotenuse, so that's 3 over 5. But it says sine squared, so we're going to square the sine value. Okay, we can do this in our head. What's 4 squared? And 5 squared? All right, what's 3 squared? And 5 squared. And these are nice because you end up with common denominators. And what is 16 minus 9? 7 over 25 is our answer. Question? All right, so let's look at tangent 2 theta. Tangent's always more complicated, isn't it? All right, 2 tangent theta over 1 minus tangent squared theta. Tangent 2 theta is 2 tangent over 1 minus tangent squared. All right, what is tangent of theta in my triangle? 3 over 4, opposite over adjacent, over 1 minus, tangent is still 3/4, but then I'm going to square it. I totally squeezed myself out of room here. And you know I want to do this one by hand and not use my calculator. So what is 2 times 3/4? 6/4. Okay, 1 minus 9/16. Okay, if I made 1 minus 9/16 have common denominators, what would 1 become? 16/16. What is 16/16 minus 9/16? 7/16. Okay, so I have 6/4 over 7/16. All right, I can do 6 times 16 and get 96. And I can do 4 times 7, which is 28. And I know that will reduce a little bit because those are both even numbers. So what would that be? 24/7. They both divide by 4. Nice. There we go. Okay, to be honest, that's a little satisfying doing it in your head, isn't it?
Yeah.
It is. Because when did you learn that math? Like late elementary? Getting common denominators? Like really, it's been a long time ago. But we just grabbed that calculator. Don't lose those skills. Okay, so unfortunately, we saved the most tricky one for last. I know, I should have done it first. I know.
So the most tricky or least?
The most tricky. Okay, but we are probably going to rely on our calculators pretty heavy for this one. Okay, here we go. Sine of theta over 2, cosine theta over 2, tangent of theta over 2. These are called half-angle identities. The reason why is pretty clear. You're taking half of theta on all of these. So these enable us to find things like sine of 22.5 degrees. Exact value, because 22.5 is half of an angle that's on our unit circle, 45. So it enables us to take angles that are on here, but find half of their sine, cosine, or tangent values. Okay, so the very first one is 22.5. We are going to use half-angle identity to find the exact value. When I give you exact in the directions, that means I do not want a decimal, of cosine 22.5. Clearly, 22.5 is not on the unit circle, but 22.5 is half of 45. So I'm going to call this 22.5 45 over 2. That should be a 5 there. Okay, so 45 over 2 is what 22.5 is. Okay, I'm going to go up here. This is my formula. Notice that there's a plus or minus out front. Okay, the rule with plus or minus is you just have to make the decision. Okay, so 22.5 is in which quadrant? Quadrant 1. Would cosine in the first quadrant be positive or negative? We need to use positive. Okay, so you just have to choose which one it should be. Okay, so ours is positive. For the first step, I'll put a plus out in front just to remind you that we made that decision. Big square root. 1 plus cosine theta. What is theta? 45. Okay, so this is what gets people. This right here is theta in the formula. Theta divided by 2. So yes, I'm finding cosine 22.5, but I'm rewriting that as 45 over 2. So in the formula, when I see theta, it's 45. Is everybody okay with that? Over 2. Okay, so that doesn't look so tricky. So, next step, square root 1 plus, what is the cosine of 45? What? Square root of 2 over 2? Yep. And all that's over 2. Okay, so if I want to add this up top, I need to get common denominators. If I turn 1 into a fraction with the same denominator as over here, what will this fraction be? 2 over 2. 2 over 2. There's my 1. Okay, so now I have common denominators. I have 2 plus square root of 2 over 2 all over 2. There's just 2's everywhere. Okay, this is actually 2 over 1. So let's simplify. Well, I'll set up keep, change, flip on this one. Keep the first fraction, change to multiplication, flip the second one. So that becomes, I bet you've never had a square root under a square root before, have you? And it's actually okay to have. 2 plus square root of 2 times 1 is 2 plus square root of 2. 2 times 2 is 4. Okay, but 4 is a perfect square. Square root of 4 is more 2's. We got rid of 2's, now we're getting more 2's. Okay, so I'm going to change this. I'm going to put one more step in here. I took that fraction that's under the radical and made it a fraction of 2 radicals. Okay, that's a legal math move. And then the square root of 4 is just plain old 2. So I have square root of 2 plus the square root of 2 over 2. And that is the exact cosine of 22.5 degrees. Now, type that in your calculator and see if we get the same thing. The graphing calculator definitely will not, but on the little one, let's see. Won't give it to me. So guess what I will be looking for on the test? All of that. Now, what I could do is type all that in and make sure I'm getting the same decimal. But that's it. A little tricky, isn't it?
Yeah.
Any questions on that one before we do one more? Okay. All right. Last example. Find the exact value of sine 75 using a half-angle identity. Then compare the answer found in example 2. Okay, so if I'm using half-angle identity to find 75 degrees, which angle am I using? 150. Because 150 divided by 2 is 75. If you're not sure, just double that answer, right? Okay, so I'm going to say sine of 75 is sine of 150 over 2. I'm using 150 because it's on the unit circle. This becomes theta in the formula. All right, so it's the sine formula. Go back up here. I have to decide, is it positive or negative? Which quadrant is 75 degrees in? Quadrant 1. Everything is positive in quadrant 1, right? So we just need to use the positive. Big square root. Looking up at the formula, it's so similar to the one we just used. 1 minus cosine 150 over 2. Okay, I'm going to go to the unit circle. 1 minus cosine 150 is negative square root of 3 over 2. And all that's over 2. Let's make that plus. Now, if you would like to use your calculator for some of this, this is what I would use it for. Add that together up top. And it should maintain that radical for you. So 1 plus square root 3 over 2. Okay, so I got, now I can do it by hand just like I did before, but if I'm using my calculator, that's where I would use it. And I'm going to change just the numerator to this. Square root of 3 plus 2 over 2, and then I still have that over the other 2. But that 2 is over 1. You got it. multiply. I'll do the shortcut this time. Square root of 3 plus 2 over 2 times 2 is 4. Well, I can split that again, just like I did before, into 2 radicals. Instead of a fraction under a radical, I can do a fraction of 2 radicals. And the square root of 4 is just plain old 2. So I have square root of square root 3 plus 2 over plain old 2. Now, look back at example 2. What did we find in example 2? Example 2, we were also finding sine of 75. But we used sum and difference identity there. It shouldn't matter which formula I use. We should get the same answer, right? Okay, so square root 2 plus square root 6 over 4. I'm going to write that down here. Square root 2 plus square root 6 over 4. Do those look like they'll be the same? Not particularly, but let's compare their decimals and see if they are the same. Okay, so for the first one that we just did, square root, y'all see my calculator? There we go. 3, oops, nope. Let's try that again. Big square root, new square root, 3 plus 2 over 2. 0.9659. Write that down. 0.9659. Okay, let's try this one. Fraction, square root 2 plus square root 6 over 4. Same thing. Cool. So, looks very different, but actually same number. They just look different because we used a different formula to get to that answer. Using half angle here, using some difference here. Which one do you prefer? That one? New one? Old one? No opinion? You like the new one? Oh, neither? That's not an option. Nope. First one, that's the one I prefer too. I just think that's way simpler, isn't it? But even though the answers look different, they are actually quite the same. Any questions? None of the above was your answer? Okay, so what you are doing now, hopefully you did finish 1 through 8 yesterday on the homework. So you are just turning that little page over, and we're using the new formulas, half angle and double angle on the back side. Okay? The end.